Welcome, ladies and gentlemen. Today we're connecting with what we've done all week with graphing inequalities in system form. So the first thing we want to do is identify the type of graph that we will be graphing. So as we look at these two inequalities, I want to identify that my first equation is a parabola so that I know exactly what I'll be graphing before I graph it. And then the second equation is a line. So as I go to graph, I'll graph the first inequality in red, which is going to be a parabola, and the second inequality in blue, which is going to be our line. So if I look at my parabola, I notice for the parabola that the vertex is going to be at 0, 4. And the other significant thing about the parabola is that it's going to be downward facing. How do I know it's downward facing? Because of the negative in front of the x squared. So I'm going to start my graph up at 1, 2, 3, 4, 0, 4 for my parabola. And then I'm going to either go to my graphing calculator to come up with these points or recognize the pattern of 1 squared is 1. And then 2 squared is 1, 2, 3, 4. And then go in the downward direction because I noted before that it was downward facing. I'm going to draw in my curve and use a solid line because of the less than or equal to symbol. The next thing I want to do is focus on my X marks the spot origin and test the origin to see if it's true or false for the problem. So if I test the origin, I'm going to go ahead and plug in 0 for y and then also 0 for x. So when I do that with my parabola, I evaluate and I get 0 less than or equal to 4, and I have to decide whether or not that's true or false. That is true. Therefore, I shade towards 0, 0, which correlates to inside my parabola. So I'm going to shade inside my parabola for trueness towards 0, 0. So I did all of that work for my parabola. Now I have to go back to my linear equation and graph that as well, because here's my system. So for my linear equation, I have a slope of 2 over 1 and a y-intercept of 0, negative 4. And I'm doing that in blue to color code it. So I'm going to go down to the point negative 4, 1, 2, 3. So what I'm going to do again is plot my y-intercept at 0, negative 4. So 1, 2, 3, 4. So there's my y-intercept at 0, negative 4. Then my slope tells me to go up 2, right 1, up 2, right 1. And I look to see I am going to draw in a solid line because of the greater than or equal to symbol. Don't have a whole lot of room, but I want to test out my region of 0, 0. So I'm going to plug in 0 for my linear equation and check and see is it true or false. Okay, so 0 greater than or equal to negative 4, is that true or is that false? It is true, so that means I would shade towards 0, 0. So as I'm shading towards 0, 0 on the line, what I have to see is what do they have in common. So what they have in common is what I'm going to highlight now in black. My actual solution region is everything underneath the parabola bounded by the blue line here. So there's my solution region. So what you can do is do what you got to do to get that very clearly highlighted for your teacher. What I'd like you to do now is pause the video and work on number 2. Check your solution by pushing play when you're completely done with the problem. Okay, for number 2, after you had time to complete it, some things I want you to check. Did you dash the line? And then did you put a solid curve in? The solution region is highlighted in black, as you can see. So check your work on that. And then what we're going to do is move on to number 3. We'll do number 3 together. Okay, so for number 3, we want to identify first the two shapes that we're talking about. So again, our first graph is a parabola, and then we want to identify the second graph before we even go through it is going to also be a parabola. So here's our first example of two different parabolas on the same graph. Okay, so on the first problem, we're going to start down on, and I wish there was more room, but I'm going to go ahead and keep it color-coded. So the vertex of that first graph is going to be at 0, -5. And I noticed that there is a 2 in front, which tells me it's upward facing, and because it's greater than 1, it's actually going to narrow the graph. So I'm going to start my graph at 0, -5, 1, 2, 3, 4, 5. And again, if you're not confident with these points, you can always go to your table function on your graphing calculator. Instead of going right 1, up 1, I'm going to go quicker than that because of the stretched nature of the graph. So I'm going to go right 1 and then multiply that by 2. So that's my first point. And then instead of going right 2 and then quickly up to 4, I'm going to go even faster and go all the way up 8 units because I have to double that. So I'm going to go right 2 and up 1, 2, 3, 4, 5, 6, 7, 8 units. So it is a very thinned out parabola. If I look, my inequality is a greater than symbol, so that tells me I should use a dashed curve. So I'm dashing that. And then I have to decide whether or not to shade towards 0, 0 or away from 0, 0. So if I plug in 0 into my inequality, the y cancels, and then 2 times 0 squared, the x cancels, and I'm left with 0 greater than -5. That is a true statement, so that means I am going to shade towards 0, 0. And that's going to correlate to inside the parabola. So I'm going to graph or shade inside my parabola here. Okay? So I've completed the first curve. Now I have to look at the second curve, which is also a parabola. I have to do a little bit of manipulating. So on that one, I'm going to go ahead and add x squared to both sides. So I end up with y is less than or equal to, if I add x squared, it's going to be x squared plus 4. So then that tells me my vertex is at the point 0, 4. And then if I look in front, I don't have a number written in, which is implied that it's 1. So that means it's upward facing and it's not condensed or compressed. So I'm going to go to the point 0, 4, which is really hard to see. 1, 2, 3, 4. And then I'm going to go ahead and graph to the right 1, up 1, to the left 1, up 1, to the right 2, 1, 2, 3, 4, and then to the left 2, 1, 2, 3, 4. If I look at my inequality, it's less than or equal to, so that means I'm actually going to draw in a solid curve. And then I have to decide whether or not to shade towards 0, 0 or away from 0, 0. So I just put in yellow the X to identify where is that 0, 0. It's always best to go back to the original inequality when you test your points. So I'm going to rewrite negative x squared plus y is less than or equal to 4 just so I have some room. And I'm going to plug in 0 for x squared, or 0 for x, and that cancels to 0, plus 0 for y is less than or equal to 4 is the question that I have. Is 0 less than or equal to 4? That ends up being a true statement. So what that means is I have to shade towards 0, 0. So what that's going to look like is I'm shading outside of the parabola instead of inside of it. So I'm going to shade outside, and if you notice as I'm shading, I'm bounded by the other parabola. So again, I'm going to highlight in black, then my final answer is everything above the red parabola, but I need to stop at the blue parabola. So what does that solution region look like? What I'm highlighting right here in the black. And it actually goes up infinitely as well, so it'll continue to go up. What I'd like you to do now is pause the video again and work on number 4. Once you're completely done with number 4, go ahead and put play, and then you should be able to see the solution to it and check your answer. Okay, if you could check your work on number 4, some things you should be looking for is the first inequality is a parabola that's downward facing. Did you dash as I did on the red parabola? And did you use a solid curve on the blue parabola? So the solution region then is what I have highlighted in black, which is below the blue, and also inside of the red. So that's highlighted in the black. So check your work and hopefully it went well. Okay, so as we work through number 5, we want to identify again that the first graph is in fact a parabola whose vertex is at 0, 1, and that it's upward facing. And the second graph is a parabola whose vertex is at 0, -3. And not only is it upward facing, it is going to be a vertically stretched graph because of the number greater than 1 in front of the x squared. So I am going to go to the point 0, 1 for my first parabola, and that's my vertex. It's upward facing, so I'm going to go ahead and put in my points 1, 1, and then -1, 1, 2, 4, -2, 4. And when I'm stating those points, I'm always stating them with respect to the vertex. So they're shifted up 1 unit because of the +1 on the equation. If I test out the point 0, 0, again, it's my origin. If I test that out on the first one, I end up with 0 less than 1, which is a true statement. So that means I'm going to shade towards 0, 0 instead of away from it, but I still have to draw in my curve. My curve is going to be dashed, and I have to shade towards 0, 0, which means I'm actually shading outside of the parabola instead of inside. My suggestion as you guys are shading is to use a pencil and lightly shade. I don't have that option for what I'm doing. Actually, I do have a pencil option, but anyway, I'm shading it in red outside of the parabola. So now if I continue on with the blue parabola, the second equation, I'm going to go down to 0, -3. It's going to be upward facing, but it's going to be very thin. Instead of going right 1, up 1, I'm going to go right 1, and I'm going to go up really quickly to 3 on both sides. And then instead of going right 2, up 4, I have to go up really quickly 3 times 4. So I'm going to go up 12 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is my next point. So you can see it is vertically stretched, and it just shoots up very quickly. So on that blue parabola, the second one, I'm going to use a solid curve because of the less than or equal to. And then what I have to do is decide whether or not I should shade inside, which is towards 0, 0, or outside, which is away from 0, 0. So I'm going to go ahead and test out that point down here. So is 0 less than or equal to -3? That is false. 0 is not less than, so I have to shade away from 0, 0. So if I'm shading away from 0, 0, that means again I'm shading outside of the parabola, so I want to see where these points intersect. This is not going to look too nice. Let me see if I can use a highlighter to show this. So I have to make sure that I'm bounded by the blue and the red, so the red goes out a little bit wider. So let me try and highlight this maybe in yellow. I don't know how this is going to show up, but I believe the solution region is going to be everything outside here then. But I have to make sure I don't cross over the yellow or, oh, I wish I was using the highlighter the whole time now. Oh, well. I have to make sure I don't go past the red or the blue part of the curve. So that yellow is going to be my highlighted and my solution region. Okay, for these last several questions, it's asking us to write a equation or inequality based on the curves given. So if you look at part A, there are no shaded regions. So all we have is actually a system of equations. So where they're meeting at are at these 2 points right here. So what equation would make that true? Well, we have a linear equation that goes right here, and the quadratic equation is that graph right there. So what I can do is find a way to set those two equal to each other. So right now, I have one equation solved for y. I'm going to go ahead and take x plus 2y equals 4, which is a linear equation. I'm going to solve that equation for y so that I can use substitution to write my equation. So what I'm doing is using some algebra to get y alone. So y equals negative x over 2 plus 2. So now that I have this equation solved for y, I can set them both equal to each other, because if you notice here, I have y equals negative x over 2 plus 2, and y equals negative 1/3 quantity x plus 3, quantity x minus 4. So then what equation makes these true is negative x over 2 plus 2 equals negative 1/3 times the quantity x plus 3 times the quantity x minus 4. So that is the equation that would make these this graph true. As I look at B, again, I have a linear equation mixed with a quadratic equation. So there's my line that is dashed, and then there is my quadratic equation, my parabola, that actually has a solid curve to it. So what I can do is I can think about the equation x plus 2y equals 4, and I want to actually change that into slope-intercept form by subtracting x. So I get 2y equals negative x plus 4. And then that y, if I divide each part by 2, I get y equals negative 1/2 x and then plus 2. If I notice, I have a dashed line, so that is going to be y, and it's being shaded above, is greater than negative 1/2 x plus 2. That's the first part of my system of inequalities. The second part, if you notice, it's already in y equals form, and I'm going to say y is less than or equal to negative 1/3 times the quantity x plus 3 times the quantity x minus 4. And the reason I knew it was going to be less than or equal to was for a couple of reasons. Number one, it's shaded below the curve, so that's the less than. And number two, it was a solid curve drawn in, so that's why I put the equal to on there as well. All right, why don't you guys push pause and then try the next two and then check your answers in a minute. Okay, go ahead and check your answers to C and D. The only thing bounded on C is by the parabola, so I just wrote in y less than or equal to negative 1/3 times the quantity x plus 3 times the quantity x minus 4. And then something different on D, first of all, it was below the parabola, so that's why I have y less than or equal to the equation for the parabola. It was above the line, but dashed, so I said y greater than or equal to negative 1/2 x plus 2. And then the newest thing is it was also bounded by this vertical line right here, which it looks like it's a solid line, and that's the equation x greater than or equal to 0. So that's our third inequality for this example. So hopefully the video helped, and what I'd like you to do now is work on the homework for today. Have a good weekend.